As you can see, I've already shown most of my working out for this question, so I'll just talk you through it. We're given the curve C that's defined by the parametric equations. X is 1 minus t squared over 1 plus t squared, and y is 2t over 1 plus t squared. We need to work out the coordinates of the point of intersection between the curve and the straight line with the equation 3y is equal to 4x. So points of intersection, I'm thinking simultaneous equations. So what I have done is I've taken my y function and substituted it in here, and I've taken my x function and substituted it in there. That's what's giving this line here. Next thing is I looked at those fractions and thought, oh, they look absolutely horrible. But thankfully, our denominators are the same, 1 plus t squared on both sides. So I've just decided to multiply both sides by 1 plus t squared. That way, they will cancel out. And that brings me to the next line, where I've expanded the 3 times 2t to get 6t, and I've expanded the 4 times the 1 minus t squared to give 4 minus 4t squared. It's a quadratic, so put everything on one side. I've divided through by 2 just to make the numbers a bit smaller and a bit easier to help me to factorise, which I can then solve to find the two values of t where the curve and the line intersect. So if t is 1/2 or minus 2, then the curve and the line will intersect. We want the coordinates, so the x and the y values, when that happens. So first, let's consider what happens when when t is 1/2. So I've plugged 1/2 in here and here to work out what the x coordinate is when t is 1/2. Then I've plugged 1/2 in here and here to work out what the y coordinate is when t is 1/2. So when t is 1/2, the curve and the line intersect at the x coordinate 3/5 and the y coordinate 4/5. And then I've just repeated that exact same process for when t is minus 2. So plug it in here to work out the x coordinate, plug it in here to work out the y coordinate, and we find that that's the coordinate minus 3/5 and minus 4/5.